Now let's go back to our use case of a satellite downlink and see how we can create all the necessary functions and resources. If I go back to our service definition for a satellite downlink, then we see several building blocks, all corresponding to the functions in our system. So we have here a source, satellite, antenna, and so on and so on. Here you see a list with all the available functions in the system, and simply by dragging them into the service definition, they can be used for a booking. Let's have a closer look on this demodulating function and see how this is really built inside the system. For that, I'm first going to the Protocol and Templates app, and we see that we have a protocol RX8200 over here, and also a Novelsat NS2000. Both of these can demodulate a particular signal. And you see indeed we have here a function underneath the protocol, decoding, demodulating, descrambling, and for Novelsat we only have the demodulating function. Now how can we specify in DataMiner that an RX8200 device is capable of demodulating, descrambling, and decoding? Well, this is done via a function XML file. Let's open here an example. This is the function XML file for the RX8200. I will open it with Visual Studio, and if I collapse some stuff here, you see that the first tag we have is a version. And the version is corresponding to the version that we see here also in DataMiner. So in the protocol and templates, you know you have all your protocols, all the versions of a protocol, but a bit down you now also have function files, and this one is the function file that I'm currently opening. The next tag that we have in our function XML file is the protocol tag, and here we see the name of our protocol, the Ericsson RX8200. And next we see that we have 1, 2, 3 functions that can be extracted from the RX8200 protocol. These are corresponding to these functions over here. So let's open the first one. This is actually the demodulating function. First of all, a function has a unique ID. Next is a name. So this one is called demodulating Ericsson RX8200. Then we see a max instances attribute. This means that a maximum of 100 instances can be active at the same time of this function. Next we have a profile. This is a GUID of it's a link to a profile definition. Each function has always a fixed profile definition linked to it. And then we also have a parent, but I will come back on that in a second. So this is how we define a function. Inside a function, we have a few other tags. The first one are parameters. Here we see a list of all the parameters that are responsible for demodulating a particular signal via an RX8200. Each of these parameter IDs are corresponding to actual parameters inside the Ericsson RX8200 protocol. These can be read parameters or write parameters. Okay. The next tag is the entry points tag. And over here we have a link to or a reference to a parameter ID again. This is a table parameter. Now what is an entry point table? That is actually the table from which resources can be created in your system. So each Ericsson RX8200 has a table from which we can create demodulating resources. And if I have a look at such an RX8200 element, and let's open this one in London. If I go to the satellite input table. Here we see 4 inputs for an RX 8200. 4 inputs each can demodulate an incoming satellite signal. So for each of these, we can actually create a resource in our system. Each of them can be booked separately. And this table, this satellite input configuration table, this is table 1600. This is our entry point table. From this table, we will create our resources. Let's collapse this again. The export rules I will skip for now. I'll come back on this later. And then, very important are the interfaces. If I have a look again to our building block here, we see that this demodulating block has, of course, the name, but it also has here 3 interfaces: an L-band input interface and an IP and ASI output interface. Well, these interfaces also need to be defined in your function XML file. And that's done as follows. We have a tag for each interface. They have a unique ID. It has a name. This one here is L-band. It corresponds to this L-band interface. And it's of type in. It's an input interface. And again, each interface has a profile definition linked to it. Same is repeated for the IP, but this time it's type out with a different profile definition linked to it. And same for the ASI out. Now, this being said, we actually already have enough information to create resources in our system. So before I continue describing the rest of this file, let's jump to DataMiner and show you how you can upload such a function XML file. So once this one is ready, you go to your protocol and templates application and you can upload this XML file just like a protocol. Okay. As soon as you do that, you will see under the section functions file, you will see that there will be a row for your function file, for the version that you just uploaded. Just as a side note, note that each time you upload a new function XML file, the file name needs to be unique. Okay. So this one is here called rx8200_functions_1007, and this one is the actual version number inside it. So once it's uploaded, you have to right click it and you need to specify set as active functions file. Only then it will be applied in the system. Once you do this, you will see this check mark over here, and you will also see that the functions defined in the file will appear right below the protocol name. Each function has also a specific icon. This is the default icon for a function, but this one can be customized, as you can see over here with custom icons. So once your function is active, you specified that from an Ericsson RX 8200 you can have a demodulating function, for example. You can go to your resources application. At first there will be no resource pools available, as you see right here. So you can just create the resource pool. You select here this global icon and then press add. You specify the name of your pool and that's it. I created here a pool for each of my functions, so all my demodulating functions will be all in this pool over here. So you select your pool and then you can add new resources by clicking add function button here on the bottom. Then you come on this window over here and you will see again all the available functions in the system. And I'm taking now the demodulating Ericsson RX 8200 function, the one from here. And now you see all the providers. These are all the elements that from which you can create a resource. These are all my RX 8200 elements. And when I click on one, I see that I have, for each of them, I have 4 possible resources that I can create from it. These are the instances. Why 4? Well, these correspond to my entry point table. The one that I showed you earlier, this one. So for each of these, we can create a resource. Well, we see now the same thing over here. We have 4 possible resources that we can create from it. And we see that from the first instance in the table, there is already a resource created for it. We can create now a second one for the second row in this table by clicking create. I'll hit OK. And now you see this new entry appearing here in my pool. This is a new resource that is created. I can simply double click this one. I can give it another name. This is coming from my London RX 8200 dmods 5, let's call it like this. I will come back on the rest of these details a little bit later. So this is the resource that I just created. Now actually, if I go to that same element and I go to the general parameters on the data side of my element, and then I go to resource info, there is a table, the generic DVE table, and this one holds all the created resources from this element. Now you see that this one here appears. This is the one that I just created, and it has a DVE state which can be enabled or disabled. So let me enable this one now. And then we'll see that here in my surveyor, a new DVE is appearing, a new function DVE. This is corresponding to the function now. And if I open that one, this one is holding all the parameters as I defined them in my function XML. So all these parameters are the parameters that you see now in this function DVE. It's a child element that is created from your main RX 8200 element. These elements will then also be included in your service as soon as DataMiner or there's a booking that is starting. Well, DataMiner will create a service, and if this resource is booked, it will include that element inside the service. So you can monitor the service and of course the function itself. Now if I go back to my function XML file, I can now explain what are the export rules. The export rules are basically defining how the parameters need to be arranged inside your function DVE. You see that in my newly created resource, I have 3 pages with parameters inside. Well, to know on which page which parameter needs to be displayed, we have these export rules. There are quite some, but I have good news for you. All of this information that I just described to you, all these GUIDs, all these export rules, all these parameter IDs, you don't need to add them all manually inside this XML. There is a very nice feature in the DIS tool in Visual Studio, and that's called the function editor. And with this function editor, you can basically build this entire XML from scratch without having to worry about syntax and GUIDs and all of that. What do you need to do to use the function editor? Of course, you need your function XML file opened, but you need 2 additional files opened as well. You need your protocol XML and you need your profile XML file. The protocol is the protocol file of, in this case, the RX 8200, And the profiles XML is a file which you can find in the file system of the server. If you go to C, Skyline DataMiner, and then you go to profiles, or profile manager, you have here a profile XML file. This one, I will quickly copy it into my folder here, and I will also copy my protocol. This one is also available over here, Ericsson RX 8200, the production version. This is my XML file. And if I now open these two files as well, so my protocols and my profiles, I can now hit the function editor, and then you see this UI. So on this UI you see it's a bit like editing a protocol in Visual Studio with DIS editor. You can specify pages over here, you can add new pages, and you can drag all the parameters from the Ericsson RX 8200 that are responsible for a particular function, just like this inside your inside this pane over here, and that's basically how you can specify your function. You have also all your functions here on the top. This was here for my demodulating function, same counts for my descrambling function, and so on. I can also create new functions inside just by adding or clicking this button. Give it a name, you select your profile. This time it's showing the names of the profile definitions. Your entry points, these are the tables inside the protocol. You specify all of your interfaces that you need, the type of your interfaces. Again, you link a profile definition to it. All of this is the same as I explained already before, but now with some UI. So as soon as you did everything you needed, you can hit the apply changes and it will generate the XML for you. So this makes things a lot easier, of course. So this way you can build all of your functions for a particular protocol. As you could see, we have more than one function inside this XML file. I also have a function for my descrambling. I also have here my decoding function. So the story is the same way. You specify your parameters, your entry points, if any. So that's an optional thing. The export rules, and then the interfaces. Now I want to come back on one specific attribute that I skipped, and that's this parent attribute. In DataMiner you probably saw that I have here my decoding function and my demodulating function, and underneath I have here two real functions, the one from Ericsson and the one from Novelsat NS2000. This is actually my parent, and I specify this inside this function and inside this function. Okay, and that's also what you see here. This is the demodulating from the RX 8200, and it has a reference to this parent. If I would open the function file from the Novelsat, from this function here, from the Novelsat NS2000, then you will see that this function will also have a reference to the same parent, and that is the demodulating parent. Now, where do you specify these like system-wide functions? This is done in a file, also in the file system of DataMiner. So if you go to the C Skyline DataMiner folder again, you have a folder Service Manager, and inside this one, if not exist, you can create this function XML file. And inside this function XML file you see, let me maybe copy this to Visual Studio. It's an XML file. And if I collapse some things to keep the overview, you see that there are a few functions defined here as well. One of them is my demodulating function with this ID. This GUID here is corresponding to the GUID that you see here. Okay, so you specify here a function. This one is not tied to any protocol. This is just as acting as a parent. This one has no parameters because the parameters are defined on this level here. But very important, they have the exact same interfaces and profiles linked to it. So this one is exactly the same as, or it's an exact copy of this over here. And this on his turn is also an exact copy of the part inside the novelstat function. Okay. Optionally, you can also add a graphical. I didn't tell you over here, but also here you can add an extra tag for an icon. So as soon as this function is ready, you can save it, of course. You can upload it to that service manager folder. You can restart your DataMiner agent, and as soon as it comes up, then you will see here that where is it in my services app? You will see that both the functions will appear underneath your parent function, your demodulating function. And basically you are going to book a demodulating function and not one of these, because you don't care from where your demodulating function is coming. You just want a signal to be demodulated. Whether it's with an RX 8200 or a novelstat, that's decided at a later stage. So now that we know how we can extract functions from our products, let's have a closer look again at our satellite downlink. So let me maybe discard all my changes and let's run through all the functions. The first block, the first function, is our source function. This one corresponds to the channel that we want to downlink. How is this function built? Well, for this one, we have a driver called the Skyline generic source, and I have here such an element. Let me show you what's inside. And we see here that there is a source table or a satellite table with all my channels that I manually entered. Okay, so I can manually add here as many channels as I want. Of course, this could perfectly come from an external inventory. All right, but for now, this is for this demo added manually. And each of my channels have particular settings. They have a frequency, a symbol rate, polarization, everything that is specific for that particular channel. Now this driver is actually doing a little bit more than just storing the source channels. It's also able to create profile instances for you. So if I go to my general tab, and if I would add a new source inside this table, I will call it my channel. I define that this source is actually a satellite source. So I will disable the IP and I will enable the sat. If you eventually then go over here to that table from which I'm creating my resources, my source resources, I can now just fill in all the details of this particular channel, the frequency, the polarization, and so on. Or if it's high band or low band, the orbital position. And once ready, I can commit this channel. And if you go to source management, with these buttons here, you can check if all profile instances are up to date, or you can create new profile instances from here. So this saves you actually a lot of time to create basically all of your profiles. How these profiles are used within SRM, I will explain in a later stage when we talk, for example, about capabilities, resource capabilities. So this is a first function that is being created in the system for a satellite downlink, and basically this function will have an entry point table looking at this table. So for each row in this table I can create a source that corresponds to the channel that I want to downlink. So that's one big function inside my service definition. The next one is our satellite function. For that same story, I have again an element. This element is using the protocol generic satellite space segment. Over here you have again a table from which you can create resources, in this case satellite resources. You can import all your satellites via CSV, and once that's done you can create resources for each of these rows, for each of these satellites inside the satellite table. So my function will have now an entry point table with ID 200, which is my satellite table. For the antenna function, separate elements are created for each antenna individually. If we look at our London site, we have here two antenna elements, one for antenna 1, one for antenna 2, and each of these elements have the protocol or are using the protocol generic satellite antenna simulation. The function for an antenna is rather easy. It does not need any entry point table. We just create a resource from the element directly. Now if we have a look again at our service definition, we see that the first three blocks in our service definition are actually functions extracted from virtual elements. These elements like the source element, the satellite element, the antenna element, are not elements that are communicating with a real device. However, the resources extracted from them is really a bookable resource. Now the next function is our matrix L-band input and output. We have a separate function for the input and for the output because they can be monitored individually. An input can have specific parameters that need to be monitored as well as the output. So if we have a look at our routers, we have here the L-band router element. So for this protocol, we have two functions, one for the L-band input and for the output. So you'll have two entry point tables inside the function, one for our input table and one for our output table. So this means that from each row in this table and each row in the output table, we can create resources in the system. Of course, also a special attention to the interfaces. We see that our antenna interface had an RF in and an L-band out. On our matrix input and output, we see that we have, of course, an L-band in and an L-band out. Now the next block in the service definition is our demodulating function. This demodulating function can come from either an Ericsson RX 8200 or our Novelsat NS2000. So that means that we need a function for both protocols and we put them underneath the same parent. So looking at our RX 8200 device, as we already quickly touched, we know that we have a table with four inputs, four satellite inputs. So for each of them, we want to be able to create a resource. So our entry point table will be this satellite input configuration table. For the Novelsat NS3000, that's a different story. We can only demodulate one signal at a time, so we can only extract one function or one resource, demodulating resource, from an NS3000. So we don't have here an entry point table for this function. However, the interfaces need to be exactly the same for an RX 8200 as for an Novelsat NS3000. Otherwise, we're not able to put them underneath the same parent. So similar story also for our descrambling and decoding functions. They are created underneath a parent, a decoding parent and a descrambling parent. However, you see that only the RX 8200 has the decoding function and the descrambling function. An NS3000, a Novelsat receiver, is not able to decode or descramble. It can only demodulate the signal. So actually we could have also created a function straight into the root here and without using no parent at all. However, to be maybe a bit future-proof, you can put them already on underneath a parent. So later on, if you have new devices, new receivers that are able to descramble, you can just put them underneath this parent. So now you know how to create or extract functions from your protocols. The next step is now to create resources using these functions from your actual devices.